Hello and welcome. You are here, and that is enough. Tonight, we are going to settle into a thought that has followed humanity since the first time someone dropped a stone and noticed it always falls. The thought that perhaps the most familiar force we know is not quite what we think it is, the idea of gravity. That quiet presence that shapes every moment of our lives, every breath we take, every step we walk, and every orbit that keeps Earth circling the sun. It is not loud, it is not bright, it does not announce itself like fire or storms. It is simply there, invisible yet undeniable. You feel it in the weight of your body pressing against your chair, in the heaviness of your eyelids as you begin to relax. You see it in the way rivers carve valleys, in the way oceans rest in their basins, and in the way trees grow upright, reaching skyward before arching back down with fruit that must eventually fall. Gravity is ordinary, but it is also the quiet architect of everything. Without it, there would be no planets, no stars, no galaxies, no us. But what if gravity is not what we think it is? What if this most familiar of forces is, in truth, something stranger? What if our understanding of it is only a shadow on the wall, while the real thing sits beyond our reach? That is the journey we begin tonight, a slow, patient walk through history and science, with pauses to notice how the world feels in the presence of gravity. Because before we can question it, we must first honor how deeply it shapes us. Imagine, for a moment, you are standing in an open field. The ground is firm beneath your feet. Above you, clouds drift in the sky. Far beyond those clouds, the moon moves silently in its orbit, its pull gently tugging on the oceans, raising tides that march in and out with steady rhythm. Beyond the moon lies the sun, immense and blazing, holding Earth in its endless curve. This little planet of ours does not fall into the sun, nor does it drift away into the cold dark. It circles, balanced between motion and attraction. That balance is gravity at work, and farther still, the sun itself is tethered by gravity to the larger structure of the galaxy, circling the Milky Way center over hundreds of millions of years. Every step, every motion, from falling apples to spiraling galaxies, unfolds in the presence of this invisible guide. For most of human history, gravity was not even named. It was felt, of course. It was observed. People knew that stones fall, rivers flow downhill, and heavy things resist being lifted. Ancient thinkers speculated about why. Aristotle believed heavy objects naturally sought the center of the world. Others imagined hidden properties, unseen tendencies, or spirits guiding matter. But no one quite captured it in the language of law until Isaac Newton. We will walk toward Newton soon, but let us pause here. The fact that people could live, build, farm, and dream for thousands of years without a precise understanding of gravity tells us something profound. Gravity is so reliable, so constant, that you do not need to explain it to live under its rule. It is simply there, like breath, like sunrise. And yet, once someone finally described it, the world changed. Ships could navigate with new precision. Orbits could be predicted. A falling apple could be linked to the motions of the moon. The familiar became strange, and the strange became knowable. And that is where our story begins, not with answers, but with the moment of realization that gravity is not just a fact of life, but a question. A question that is still not fully answered even today. Picture Newton in the 17th century, a man with sharp eyes and restless thoughts, sitting beneath a tree, though perhaps not exactly as the story goes. He notices the apple fall, and he asks, Not why it falls, everyone knows that, but why it falls in the same way that the moon is held. Why does the apples fall and the moon's orbit share the same rule? Out of that question came his law of universal gravitation. Every mass attracts every other mass with a force proportional to their weights and inversely proportional to the square of their distance. A simple equation. And yet, that simple line of thought could describe the paths of planets, the return of comets, the tides of Earth. Suddenly, the cosmos was not a chaotic theater of chance. It was a clock, and gravity was its spring. This was a revelation. It was also a comfort. The universe had rules, predictable, elegant, universal. For the first time, the heavens were not governed by a mystery separate from Earth. They were bound by the same law that made an apple fall. But let us linger on that comfort for a moment, because even now, centuries later, we find ourselves returning to the same question Newton asked. What is gravity? What is it really? Newton himself admitted he did not know what gravity was, only how it behaved. He gave us the mathematics, but not the mechanism. Hypothesis non fingo, he wrote. I feign no hypothesis. He could describe its pull, but he could not say why mass attracts mass. He left the mystery intact, only dressed it in numbers. As the centuries rolled on, this question deepened. Observers noticed that Newton's equations worked beautifully for most things, but not for all. The orbit of Mercury, for instance, strayed slightly from prediction. Small, but persistent, a whisper that perhaps something lay beyond Newton's reach. That whisper grew into Einstein's voice in the early 20th century. But we will not go there yet. We will stay here, in the space between knowing and not knowing. Because that is the place where curiosity grows. Let us return to the present moment. You, sitting or lying as you listen, are under gravity's influence. Your body has weight because the Earth pulls on it, but it is not a one-way story. You are also pulling on the Earth, however imperceptibly. The chair beneath you pushes back against your weight. The ground holds you firm, and you remain at rest. In these quiet details of everyday experience, the vast machinery of the cosmos is mirrored. For what holds galaxies together also keeps you in your seat. And here we arrive at a thought that will guide us through this episode. Perhaps the most familiar things are also the most mysterious. We think we understand gravity because we live with it every second. But perhaps we only understand its surface, while its depths remain hidden. What if gravity is not a force, but an effect? What if it is not a simple tug, but the visible ripple of something deeper? That is where we will walk in the coming parts. Through Newton's clockwork, into Einstein's curvature, across the strange terrain of quantum theories, and into the puzzles of dark matter and dark energy. Along the way, we will ask, gently, whether gravity is the universe's quietest riddle. Before we go on, I would like to pause. You are here, listening, sharing this moment across distance and time. If you are enjoying this quiet exploration, I invite you to like this video so others may find it, to subscribe if you'd like more journeys like this one, and to share where and when you are listening in the comments below. It is always a quiet wonder to see these fragments of time and place gather together, small lights across the globe. No pressure, only an invitation, like footprints that show we are walking this path together. Now, let us continue. Gravity has guided our steps from the moment we were born. Tonight, we will try to walk beside it, to glimpse the unseen threads it weaves. Because what if this most ordinary of forces is not quite what we think? What if it is only the beginning of the story? Newton's law of universal gravitation was not only a scientific achievement, It was a turning point in how humanity saw itself. For the first time, the same rule that governed the fall of a stone could be extended outward to the sweep of the planets. No longer was the Earth a separate stage, with its own rules, while the heavens moved in mysterious ways. Instead, all was one. The apple and the moon shared a story. Think about the courage of that idea, to claim that the same invisible tether holding your body to the Earth also guides the orbit of Jupiter. It was a bold unification, a weaving together of the near and the far, the familiar and the unreachable. People who had once looked up at the night sky and seen a realm of perfection and difference were now asked to accept that those lights obeyed the same pull that kept their feet on the ground. The cosmos had become intimate, and with that intimacy came predictability. The clockwork metaphor is not just a poetic image. For Newton, the universe was exactly that. A vast mechanical device wound up by the Creator and left to run. Every motion, every orbit, every fall could be predicted if one only knew the positions and masses involved. The solar system became a grand stage of moving parts. The tides could be explained, eclipses could be forecast, even the paths of comets, once seen as omens, could now be charted with confidence. The sky lost none of its wonder. But it did lose its unpredictability. Imagine living in that moment. Imagine seeing comets that once brought fear, now reduced to equations on paper. Imagine being told that the same law governs your hand dropping a stone and the moon circling endlessly above. It must have felt like the universe had been domesticated, brought into human thought. It was no longer an untamable mystery, but a calculable certainty. But as with all certainties, cracks began to appear. Mercury's orbit wobbled in ways Newton's equations could not fully account for. The wobble was small, just a few arcseconds each century, but it persisted. Astronomers tried to explain it by searching for another planet, one closer to the Sun than Mercury. They named it Vulcan, but Vulcan was never found. The anomaly remained, a quiet reminder that even Newton's grand clockwork might have limits. It is worth pausing here, because it shows us something about science itself. A theory does not need to be final to be true. Newton's equations still guide spacecraft today. They are accurate enough for most purposes, and yet they are not complete. That incompleteness is not failure, it is invitation. Each crack is a doorway to deeper understanding. Now imagine the 19th century, with scientists building ever more precise instruments. Telescopes scanning the skies, clocks measuring time with growing accuracy. Every observation a test of Newton's law. For most cases, the law held beautifully. But the problem of Mercury was not the only whisper. As measurements became sharper, astronomers began to wonder whether unseen forces might lurk in the data. If Newton was not wrong, perhaps the universe held hidden actors. This is where we begin to sense the edges of Newton's vision. His gravity was a force, acting across distance. Every mass pulled on every other, instantaneously. That last word is crucial. In Newton's universe, the Sun exerts its pull on Earth without delay. If the Sun were to vanish suddenly, the Earth would instantly fly free. But is that reasonable? How could action travel without time, without medium, across space? Even Newton admitted unease. He gave us the law, but not the explanation. What carried this force? What filled the empty space between bodies? He had no answer, and so the mystery endured. Gravity was law-like, predictable, measurable. But it was also inexplicable. Newton knew it. The scientists who followed him knew it. They could describe how it worked, but not why. This is where we return to a simple thought. the most familiar things often carry the deepest mysteries. Gravity is everywhere. It governs your weight. It shapes rivers. It binds the earth. And yet, even as we write equations and launch satellites, we still ask the same question Newton left unanswered. What is gravity really? The 20th century would bring Einstein, and with him a new picture. But before we step into that vision, it is worth pausing in Newton's world to appreciate its clarity and its limits, because in that pause we can feel the shift. A world once mechanical would soon become elastic. A cosmos once wound like a clock would soon bend like fabric. The step from Newton to Einstein is not only scientific, it is poetic. It changes the metaphors we use to think about existence. But let us stay here a little longer. Picture the solar system through Newton's eyes. Planets circling in predictable paths, moons locked to their parents, comets swinging out and returning centuries later. Gravity as the silent thread holding it all. There is comfort in that picture. Comfort in knowing that the universe can be charted, that the heavens are not chaos but law. It is a vision that gave people confidence to build, to navigate, to explore. It gave sailors a way to cross oceans with precision. It gave astronomers the tools to map the heavens. It gave engineers the confidence to build machines that would later leave Earth itself. But it also gave us something subtler. It gave us a sense that the universe is noble, that beneath the shifting lights of the sky lies order, that human reason can uncover it. That is not a small gift. It is a profound shift in how we see ourselves, not as wanderers lost under an unpredictable sky, but as beings capable of understanding the invisible rules of the cosmos. And yet, even in this triumph, there is humility. Newton's own refusal to guess at the cause of gravity is a reminder that knowledge always carries shadows. He wrote the equations, but left the essence untouched. He could predict the path of the moon, but he could not say what gravity was. That humility is part of science too. Now let us glance forward. Imagine Einstein as a young man, wondering not about apples and orbits, but about light and speed. Imagine him riding on a beam of light in his thought experiments. Imagine him asking what happens if you accelerate forever, if you fall freely, if you stand still in the cosmos. Out of those thoughts would come a new vision of gravity, not as a force, but as the shape of space-time itself. Not as attraction, but as curvature. The apple does not fall because Earth pulls it. It falls because it moves along a bent path in the fabric of reality. That vision is waiting for us. But before we step fully into it, let us rest here with Newton a little longer. Because this part of the story shows us something essential. Every answer is also a question. Every law is also an invitation. Gravity may have felt explained under Newton, but its essence remained untouched. And in that untouched space, curiosity waited. So here we end this part, standing with Newton beneath the apple tree. The apple falls, the moon circles, the planets sweep, the law is written. And yet, the question lingers, what is gravity really? Einstein's arrival on the scene changed everything, though at first it was quiet. Not a dramatic declaration, but a careful unraveling of the assumptions that had seemed so certain under Newton. He asked questions that no one had dared. What is motion? What is time? What is space? And when gravity calls objects together, is it really a force, or is something more subtle at work? In 1905, Einstein proposed that the speed of light is constant, that time and space are not separate, and that observers moving at different velocities will measure lengths and times differently. It was already a radical departure from classical thinking, but gravity waited for its turn. 10 years later, he would release the general theory of relativity, in which gravity was no longer a force acting at a distance, but a curvature of spacetime itself. Massive objects bend the fabric of the universe, and the paths of other objects follow those curves naturally, like marbles rolling along a stretched and twisted sheet. Imagine that sheet, a vast, invisible tapestry spanning the cosmos, bent here, sagging there, rippled with energy, and shaped by every star, planet, and black hole. We live on this sheet, feeling its curves in every fall of an apple, in every orbit of a planet, in the pull of the moon on the tides. Gravity is no longer a push or a pull in the Newtonian sense. It is geometry, movement along curved paths. The Earth does not pull on the moon, it warps space, and the moon follows the curve. This shift is subtle and profound at once. It changes the way we see the universe. Under Newton, gravity is instantaneous, a direct line between masses. Under Einstein, gravity is mediated by the bending of spacetime. There is no action at a distance. The fabric itself guides motion. And with this realization comes a quiet humility. For the universe is not just a machine. It is a living geometry, responsive, intertwined, and far more intricate than we can intuitively grasp. To appreciate this, picture a train of thought. Every object has mass. Every mass bends the space around it. Photons, which have no mass, travel along these curves. Light is deflected. Stars appear shifted. Black holes hide behind the warping, bending even light to their will. Gravity is no longer simply pull. It is the shape of reality. It is the architecture of the cosmos. And yet, even as Einstein's equations describe these curves with extraordinary accuracy, mysteries remained. For one, the universe is not only curved but expanding. The galaxies drift apart. Dark matter tugs unseen, holding clusters together. Dark energy pushes everything outward, accelerating the cosmic expansion. The cosmos is far stranger than even Einstein imagined. Gravity, as it turns out, is only one piece of a vast puzzle. Consider, for a moment, the feeling of weightlessness. Astronauts orbit Earth and experience free fall. They float, yet they are still under the influence of gravity. This is not the absence of force, but motion along a curved path that creates the sensation of weightlessness. It is counterintuitive. We think gravity means heaviness, resistance, pressure. But the universe reminds us that the feeling of weight is not the force itself. It is a relationship. It is geometry. Even on Earth, the subtleties of gravity abound. Tides rise and fall not only because of the moon, but because of the sun, the distribution of mass beneath our feet. From mountains to underground water, subtly affects local gravitational pull. Precise instruments can measure these differences. Clocks tick differently at different altitudes. Time itself bends under gravity's hand. That the cosmos connects weight, time, and motion in this way is a meditation as much as it is a scientific fact. Einstein's vision also opens doors to thought experiments that border on wonder. What would it be like to approach a black hole, to fall toward it? The tidal forces stretch and squeeze, elongating objects, bending light into a halo. A journey toward extreme gravity becomes a journey into the unknown. Even the familiar laws of physics begin to dance differently, yet always within the framework of relativity. Here, too, we notice a pattern that recurs in all these meditative explorations of science. The deeper we look, the stranger the familiar becomes. Apples still fall, planets still orbit. Yet the rules behind their motion are subtler, more complex, more interconnected than our senses suggest. Everyday experience gives us Newton, and imagination and observation give us Einstein. Together, they tell a story of gravity that is both ordinary and extraordinary, but there is more to wonder. Even Einstein's general relativity, as elegant as it is, may not be the final answer. Observations of galaxy rotation, clusters, and cosmic expansion hint at additional layers. Dark matter, dark energy, quantum fluctuations. Forces we barely perceive, but whose effects shape the vast architecture of the cosmos. Gravity may be emergent, a side effect of deeper realities, a manifestation of unknown fields or hidden dimensions. This does not negate Einstein. It extends the mystery. It reminds us that our understanding is provisional, a scaffold rather than a finished cathedral. The beauty of this is that we can live inside gravity and yet remain ignorant of its essence. Every step, every fall, every breath is under its sway. And yet, centuries of thought have not fully revealed it. That duality, familiarity, and mystery is what gives gravity its quiet power. It is the background to all life, the invisible stage on which existence unfolds. We can feel it, measure it, predict its effects, and still not fully comprehend it. That is a rare and profound experience. Imagine now the human body, adapted to Earth's gravity. The heart, the skeleton, the muscles all respond to this force. Plants grow upright in response to it. Rivers carve their valleys downward. Mountains rise and collapse under its persistent pull. The entire biosphere is tuned to gravity's rhythm. Remove it, and the choreography of life falters. Gravity is ordinary in our perception, yet extraordinary in consequence. At the cosmic scale, it becomes even more mesmerizing. Clusters of galaxies, cosmic filaments stretching across billions of light years, voids as vast as imagination allows. All are shaped by gravity's invisible hand. It is both sculptor and stage, force and geometry, law and meditation. Each star that ignites, each planet that forms, each comet that arcs, participates in the quiet order imposed by curvature of space-time, and yet, within that order lies uncertainty. Quantum mechanics and gravity have not fully reconciled. The smallest scales may conceal ripples we cannot yet detect. Tiny fluctuations, probabilities, virtual particles. Gravity's weave might be laced with secrets beyond current instruments, hints of a reality more intricate than even general relativity allows. Each discovery brings new questions, each answer deepens the horizon. Even in our everyday life, there is poetry in this recognition. The weight in your hand, the step you take, the descent of breath, all are expressions of a cosmic dialogue, a subtle conversation between matter, motion, and space-time. Every motion under gravity is a trace of a geometry stretching across the universe, a curve connecting the body in this moment to stars light years away. Perhaps this is why gravity has inspired thinkers not only in science but in philosophy, art, and contemplation. It is a force that shapes bodies and ideas alike. It teaches patience because its effects accumulate slowly. It teaches humility because even the wisest minds only glimpse a fraction of its nature. It teaches wonder because the ordinary, the falling apple, the orbiting moon becomes extraordinary once we look closely. And so we move from Newton's clockwork to Einstein's curves, from the intuitive to the abstract, from the calculable to the mysterious. Gravity, once a simple pull, is revealed to be a manifestation of deep structure. Yet the structure is still only partially visible, and that partial vision is enough to carry us forward into the questions that remain unresolved, into the whispers of cosmic anomalies, into the subtle hints that there is more to gravity than we have yet understood. We pause here, not to conclude, but to notice, to feel weight, to imagine curvature, to sense the elegance of a universe held together by invisible geometry, to remember that the ordinary can be extraordinary, and that every question, every subtle irregularity, every curiosity is a doorway into wonder. In the next part, we will explore the modern observations that challenge our understanding, galaxy rotation, dark matter, dark energy, and the subtle tensions that suggest gravity might be stranger than we ever imagined. But for now, rest in the quiet, feel the pull beneath you, the curvature above, the gentle sway of a universe that is both knowable and still mysterious. When we turn our attention to the cosmos on scales far beyond human perception, gravity becomes both familiar and alien. It is the same force that tethers you to your chair, yet it is the force that binds entire galaxies together. Observations of the heavens reveal subtle puzzles, patterns that hint at hidden depths beneath Einstein's equations. They are not contradictions, but invitations. They are hints that the universe may hold structures and rules we have not yet fully understood. One of the most striking mysteries arises when we examine spiral galaxies. Stars orbit their centers in elegant, circular paths. Newtonian mechanics predicts that stars further from the galactic center should orbit more slowly, much like planets at the edge of the solar system. Yet, when astronomers measure these speeds, they find a surprising truth: the outer stars move far faster than expected. The galaxies appear to defy Newton and Einstein alike. They rotate as if there is far more mass than what we can see. This unseen mass has been named dark matter. It does not emit light. It does not absorb light. And it does not interact with ordinary matter in ways we can easily detect. Yet its presence is inferred through its gravitational influence. It shapes galaxies, binds clusters, and subtly warps the cosmos. Dark matter is a reminder that even the grand visions of Newton and Einstein leave room for surprise. The familiar force of gravity is being guided by something invisible, something beyond direct human senses, yet undeniably real in its effects. And then there is dark energy, an even more perplexing phenomenon. Observations show that the universe is not just expanding, but accelerating in its expansion. Galaxies are moving away from each other faster over time, as if an unseen push is at work. Gravity, in our everyday experience, is always attractive. Yet on cosmic scales, the universe is stretching, and something we do not yet understand is causing that stretch. The combination of dark matter and dark energy reveals that the cosmos is far stranger than our everyday intuition can grasp. We may pause here to reflect. Gravity is the force that makes an apple fall. It is the force that allows you to feel weight beneath your feet. It is also the force that binds unseen matter across millions of light years. The ordinary and the extraordinary coexist. The gentle pull of Earth and the colossal curvature of galaxies are both part of the same reality, and yet they challenge our understanding in ways that make the familiar seem mysterious. Let us imagine the Milky Way from afar, swirling arms of stars, dust and gas, billions of suns moving in patterns dictated by the pull of gravity and the hidden influence of dark matter. The galaxy does not simply exist in emptiness. It is immersed in a vast cosmic web, with filaments and voids shaped by the invisible hand of gravity over billions of years. Each structure, each cluster, each filament tells a story of accumulation, collapse, and motion. It is a story written not in words but in curves, motions, and subtle forces. And yet, for all we observe, we remain in partial darkness. Dark matter is inferred, not seen. Dark energy is detected only through its effect on cosmic expansion. There are anomalies, small but persistent, in galaxy rotation, cluster formation, and gravitational lensing. These discrepancies hint at the possibility that gravity might not be exactly what we think. Perhaps it is modified on large scales, or perhaps it emerges from deeper, hidden principles. The universe, in this way, keeps its secrets patiently, showing us clues without revealing the full picture. Even closer to home, gravity exhibits subtle variations. The Earth is not uniform. Mountains, valleys, and underground structures create local differences in gravitational pull. Satellites can measure these variations precisely, mapping the contours of the planet's invisible field. These measurements are practical, guiding spacecraft, predicting tides, and monitoring changes in ice sheets and sea levels. Yet they also remind us that gravity is not a simple, uniform tug. It is a dynamic, interacting phenomenon, shaped by the distribution of mass in complex ways. At the edge of understanding, theoretical physics offers additional possibilities. Some hypotheses suggest that gravity is not fundamental, but emergent. Perhaps it arises from the statistical behavior of microscopic degrees of freedom, from quantum entanglements, from connections that are not yet fully observed. Perhaps the curvature of spacetime itself is a manifestation of something more basic, something that underlies all of existence. These ideas are speculative, yes, but grounded in rigorous thought. They are modern attempts to look beyond the veil, to reconcile the mysteries of gravity with the language of quantum mechanics. It is remarkable and humbling that a force so familiar in daily life could remain so enigmatic on the grandest scales. That same pull you feel on Earth may encode the whispers of hidden matter, the acceleration of the universe, the geometry of space, and the statistical dance of particles at the quantum level. Gravity is at once intimate and cosmic, simple and profound. It teaches patience, humility, and curiosity. It reminds us that knowing the surface does not mean knowing the essence. Let us step back and notice the human experience of gravity in this context. Every building you enter relies on an invisible thread holding it down. Every chair supports you because of the predictable pull of mass. Every step, every heartbeat, every breath occurs in a field of force that stretches unbroken from the surface of the Earth to the farthest galaxies. We live inside gravity, yet rarely reflect on its omnipresence. It is both a condition and a companion, shaping life as subtly as it shapes stars. The interplay of gravity and observation also shapes our technology. Spacecraft orbit precisely because we can calculate gravitational influences. Satellites beam information across continents, their trajectories plotted according to the curvature of spacetime. GPS relies on the slight differences in time experienced in stronger and weaker gravitational fields. Everyday technology is a testament to our ability to harness understanding of gravity, even as the fundamental nature of that force remains elusive. And yet, in all these applications, gravity preserves mystery. The anomalies of galaxy rotation, the acceleration of cosmic expansion, and the questions of quantum gravity all hint that our comprehension is provisional. Each discovery opens new avenues. Each measurement reveals patterns that challenge intuition. Each observation, from the fall of an apple to the sweep of the Milky Way, invites us to wonder. Gravity, then, is a teacher. Its lessons are quiet. They are not shouted from mountain peaks or broadcast through the media. They are felt in weight, observed in motion, measured in instruments, and contemplated in thought. The more we learn, the more complex and subtle it becomes. It rewards patience, observation, and reflection. It encourages humility, reminding us that even the most familiar phenomena can conceal infinite depth. Consider, for a moment, the possibility that gravity is a doorway, not just a force or curvature, but a path toward understanding the deeper architecture of reality. Perhaps its seeming simplicity masks a profound connectivity between matter, energy, and the unseen structure of the universe. Perhaps every measurement, every anomaly, is a footprint on the edge of revelation. We do not yet know the full landscape, but we can begin to trace its contours, carefully and patiently. As we settle with this reflection, we notice that gravity, ordinary in experience and extraordinary in consequence, is a bridge. It connects the human scale to the cosmic. It connects daily life to the vast architecture of space-time. It connects the known to the unknown. And in this connection, we find both reassurance and awe. The universe is comprehensible enough for us to navigate and manipulate, yet mysterious enough to inspire wonder. So let us pause here. Let us feel the weight in our hands, the pull beneath our feet, the curvature of space-time stretching silently across the cosmos. Let us notice that in these familiar motions are traces of mystery, that gravity, in its quiet presence, invites us to see both what is and what might be beyond our current understanding. It encourages us to look, to measure, to imagine, and to reflect. In the next part, we will explore alternative ideas about gravity, emergent phenomena, hidden dimensions, and quantum perspectives. We will consider what it might mean if the force we take for granted is only a shadow of something deeper, subtler, and more intricate. But for now, rest with the knowledge that gravity is both a constant companion and an enduring puzzle, a silent teacher guiding every step, every orbit, and every pulse of the cosmos. Gravity has long been described as one of the four fundamental forces of nature. It is the force that organizes stars, shapes planets, and gives weight to everything we touch. And yet, when we look closer, when we observe its behavior on the smallest and largest scales, it becomes increasingly clear that gravity may not be quite as straightforward as we have believed. It may be a deeper phenomenon, a consequence of other processes, or a reflection of hidden aspects of reality we are only beginning to glimpse. Consider the idea of emergent gravity. This is a perspective that suggests gravity is not fundamental at all. Rather, it emerges from more basic interactions, from microscopic information encoded in the fabric of spacetime. In this view, gravity is a statistical effect, the result of countless tiny connections and entanglements at scales too small for us to see. It is a force that appears because the universe has rules at a deeper level, and from those rules, gravity arises naturally. This concept may seem abstract, but it carries profound implications. If gravity is emergent, then the universe may be a far more interconnected system than Newton or even Einstein imagined. The pull we feel when we step onto the Earth may be a reflection of countless invisible interactions occurring across the universe. Mass does not merely attract mass. Instead, motion and energy interact, information flows, and what we experience as gravity is a manifestation of that deeper process. To approach this idea, it is helpful to imagine a hologram. A three-dimensional image can emerge from patterns encoded on a flat surface. The depth and form that we perceive are not inherent in the surface itself, but arise from the way information is organized. In a similar sense, gravity may be a projection of deeper information, a shadow of underlying processes that operate beyond ordinary perception. The curvature of spacetime could be the visible tip of a much larger iceberg. Modern physics provides hints that this perspective may be fruitful. Quantum mechanics shows us that particles are not isolated points, but exist in states of probability and entanglement. Space itself may have a discrete structure, a granularity that is hidden from our everyday senses. Energy fluctuations, virtual particles, and the fabric of spacetime are being interwoven in ways that produce the force we experience as gravity. The familiar pull of an apple or the orbit of a planet may be the macroscopic expression of phenomena too subtle for direct observation. This line of thinking also raises intriguing questions about the relationship between gravity and other forces. Gravity is extraordinarily weak compared to electromagnetism or the nuclear forces. A small magnet can lift a paperclip against the pull of the entire planet. Why should gravity be so weak? If it is emergent, this weakness might reflect the statistical nature of its origin. It is a collective effect, a gentle echo of countless interactions, rather than a direct command. At the cosmic scale, these ideas take on even greater significance. Dark matter and dark energy could be mysterious substances at all, but hints that our understanding of gravity is incomplete. The anomalies in galaxy rotation curves, the expansion of the universe, and the acceleration of cosmic structures could reflect a deeper, emergent behavior of gravity itself. The universe may be nudging us toward a more profound understanding, one in which the pull of mass is only part of a larger story. Let us return for a moment to the human experience. We walk, we lift, we sit, we fall, all under the influence of gravity. We design buildings to resist it, we send rockets to escape it, and we float in its near absence in orbit. Every daily interaction is shaped by a force we barely question. Yet, as modern science suggests, that familiar pull may be far more mysterious than it appears. Every heartbeat, every step, every gesture participates in a cosmic conversation that stretches across scales, from the smallest quantum fluctuations to the movements of galaxies. Even our own planet offers a laboratory for subtle discoveries. Gravity is not uniform across the Earth. Variations in mass distribution, mountains, oceans, and underground structures create local differences in the pull we feel. Precise instruments measure these variations, revealing patterns that hint at the hidden complexity of mass and motion. Satellite missions such as GRACE and GOC have mapped Earth's gravity in astonishing detail, revealing how ice sheets shift, oceans rise and fall, and land masses interact. These studies demonstrate that gravity is not only a universal law, but also a dynamic, living phenomenon that responds to the distribution of matter in space and time. Beyond our planet, the largest structures in the universe are shaped by gravity in ways that still puzzle scientists. Galaxies form filaments and clusters that stretch across hundreds of millions of light years. The cosmic web appears as if sculpted by an unseen hand, revealing order in what might otherwise seem like chaos. Gravity is the architect, yet the architect's design is only partially visible. We see the galaxies and the voids, but the framework, the scaffolding of spacetime and hidden mass remains largely invisible. This invites us to imagine gravity, not as a simple force, but as the organizing principle of the universe, connecting the very small to the very large. Emergent gravity theories also intersect with ideas about hidden dimensions. String theory, for example, suggests that our universe may contain additional dimensions beyond the three we perceive. These dimensions could shape the behavior of gravity, confining it to certain scales or allowing it to leak in ways that appear as dark matter or cosmic acceleration. If true, the force we feel underfoot is only a shadow of a more intricate reality, a reflection of geometry and energy beyond our ordinary experience. All of this brings us to the edge of human understanding. Gravity, the familiar force that keeps us grounded, is also a profound mystery. We can measure it, model it, predict its effects, yet its essence remains elusive. It is simultaneously ordinary and extraordinary, intimate and cosmic, and this duality is what gives it such quiet power. It teaches patience because its effects accumulate over eons. It teaches humility because even the most brilliant minds have only glimpsed fragments of its nature. And it teaches wonder because what we feel every moment may be only the surface of something far deeper. As we contemplate these ideas, it is worth reflecting on the elegance of gravity in daily life. The sensation of weight, the fall of an apple, the rise and fall of the tides, all are expressions of cosmic rules at work. Even as we consider emergent theories, hidden dimensions, and quantum possibilities, the lived experience of gravity remains constant. Our bodies and our planet are shaped by this force, and we interact with it naturally. The ordinary gestures of life, the step, the lift, the reach are embedded in the structure of the universe. And yet, this constancy does not diminish mystery, it enhances it, because something so reliable, so persistent, so ubiquitous, may also be the key to understanding realities far beyond our current perception. Gravity invites us to look more closely, to measure more carefully, to imagine more boldly. It is a teacher, a guide, and a quiet reminder that even the familiar may hold secrets. In the next part, we will explore the small-scale puzzles of gravity and its intersection with quantum mechanics. We will consider the challenges of reconciling general relativity with quantum principles and the potential implications for understanding the very fabric of reality. But for now, let us sit with the thought that gravity may be an emergent phenomenon, a reflection of deeper processes that connect the universe from the smallest scales to the largest, from the pulse of life on Earth to the motion of galaxies across cosmic time. Gravity, familiar as it is in daily life, becomes astonishingly strange when we step into the quantum realm. At scales smaller than atoms, the laws of physics dance differently. Particles fluctuate, appear and disappear, and interact in ways that defy classical intuition. Here, the smooth curves of space-time imagined by Einstein may dissolve into foamy turbulence, a microscopic texture that challenges our understanding of the continuum. The very idea of a gravitational field becomes delicate and uncertain. Physicists have long sought a theory of quantum gravity, a framework that reconciles general relativity with the rules governing the very small. While general relativity describes the cosmos on the grandest scales with remarkable precision, it does not account for the probabilistic, indeterminate behavior observed at the quantum level. Conversely, quantum mechanics excels in describing particles and forces at microscopic scales, yet it does not naturally incorporate the curvature of spacetime. Gravity sits at the intersection, both familiar and alien, teasing the limits of human comprehension. Imagine standing at the edge of a black hole. Einstein tells us the curvature of spacetime grows extreme, stretching and squeezing matter, bending light, warping time itself. Quantum mechanics suggests that at the smallest scales, fluctuations ripple unpredictably, and virtual particles spontaneously appear. The combination produces a landscape where certainty falters, where our neat models strain under the weight of complexity. Gravity becomes a phenomenon that is both continuous and discrete, smooth and jagged, ordinary and extraordinary all at once. The pursuit of a quantum theory of gravity has inspired imaginative proposals. String theory suggests that fundamental particles are not points, but vibrating strings, their oscillations producing the forces and particles we observe. Extra dimensions may exist, unseen yet shaping gravity in subtle ways. Loop quantum gravity proposes that spacetime itself is granular, composed of tiny loops that give rise to curvature in a discrete fashion. These models are abstract, technical, and speculative, yet they offer glimpses of a deeper order, a hidden architecture underlying the universe we inhabit. Even in the absence of a complete theory, the pursuit has practical consequences. Experiments attempt to measure minute gravitational effects at microscopic scales. Observations of black holes and neutron stars test Einstein's equations to extraordinary precision. High-energy physics explores the early universe, seeking imprints of quantum gravity in the cosmic microwave background. Each measurement, each observation, is a probe into realms where gravity behaves differently from the everyday experience of weight, motion, and pull. At the human scale, gravity seems constant, predictable, and reliable. Our bodies are finely tuned to its strength. We walk, we lift, we jump, we fall. Engineers calculate forces for bridges, towers, and spacecraft with confidence. Satellites orbit precisely, and our feet remain firmly planted on Earth. Yet underlying this stability is a universe far more intricate than our senses suggest. Beneath the apparent simplicity lies complexity, subtle variation, and hidden layers of reality waiting to be understood. Consider how gravity shapes the evolution of the cosmos. Stars form from clouds of gas collapsing under their own weight. Planets coalesce from swirling disks of dust and rock. Galaxies assemble into clusters. Filaments stretch across vast expanses, and voids emerge where matter is sparse. Every structure, from the smallest pebble to the largest galaxy, exists because of the pull and curvature of gravity. It is both sculptor and stage, force and geometry, constant and mysterious. Quantum effects may also have influenced the earliest moments of the universe. During the first fractions of a second after the Big Bang, fluctuations in energy density and the behavior of fundamental particles could have set the initial conditions for cosmic structure. Gravity, interacting with these quantum fluctuations, guided the aggregation of matter, the formation of galaxies, and the large-scale patterns we observe today. The universe itself is an artifact of gravity's subtle interplay with the unseen. There are paradoxes that emerge when we combine relativity and quantum mechanics. Black holes, for example, challenge our understanding of information. If matter falls into a black hole, does information vanish, violating the principles of quantum mechanics, or is it preserved in ways we do not yet comprehend? Gravity at this extreme reveals the limits of our knowledge. It is at once a tangible force and a conceptual puzzle, both deeply familiar and almost ineffably strange. Let us also reflect on the human experience of gravity in this context. Every heartbeat, every step, every breath occurs under the influence of this force. Yet we move through it almost without thought, as if its constancy is trivial. The subtle variations beneath our feet, the minuscule curvature of spacetime, and the potential quantum fluctuations all operate beyond our perception. Gravity is the silent rhythm underlying life, a constant presence in which the extraordinary unfolds quietly. Modern technology allows us to probe these subtleties. Atomic clocks can measure the influence of gravity on time to astonishing precision. Experiments with interferometers detect gravitational waves, ripples in spacetime from collisions of massive bodies billions of light-years away. Satellites map the Earth's gravitational field in fine detail, revealing variations caused by mountains, ocean currents, and ice sheets. Each of these discoveries adds a layer of understanding, yet the essence of gravity remains elusive. The pursuit of understanding gravity also inspires reflection. It encourages patience, as the forces and phenomena at play span immense distances and epochs. It fosters humility, reminding us that even our most elegant theories are approximations of a reality far grander than our imagination. And it invites wonder, because the same force that pulls an apple to the ground also orchestrates the ballet of galaxies, the curvature of spacetime, and the emergence of cosmic structure. At its heart, gravity exemplifies the interplay between certainty and mystery. We can calculate orbits, predict tides, and navigate spacecraft. We can observe gravitational waves, model galaxy formation, and test the predictions of relativity. And yet, we remain at the threshold of deeper truths. The possibility that gravity emerges from hidden dimensions, quantum entanglements, or other unknown principles suggests that our journey of understanding is far from complete. Consider the poetic resonance of this idea. Gravity is ordinary and extraordinary simultaneously. It governs our daily lives and shapes the cosmos. It is both predictable and mysterious, familiar yet elusive. Each observation, each experiment, each thought contributes to a gradual unveiling of its nature, revealing patterns while hinting at deeper structures beyond our current reach. Gravity is the stage, the actor, and the script all at once. In contemplating gravity, we also confront the limits of human perception. We sense weight and motion, but the full complexity of the force extends far beyond our senses. We observe planets and galaxies, yet their behavior is influenced by unseen matter and forces. We measure time and space, yet these quantities are not absolute, but dependent on motion, mass, and curvature. Gravity is a doorway to understanding the universe not just as it appears, but as it truly operates, both visible and hidden. And so, we come to a subtle realization. Gravity is more than a force. It is a language, a pattern, a rhythm underlying the cosmos. Its effects permeate the ordinary and the extraordinary. Every fall, every orbit, every tidal motion is an expression of geometry and connection. Even as we pursue the deepest understanding, the mystery persists, inviting us to look closer, to imagine further, and to marvel at the invisible threads that bind existence. In the next part, we will explore gravity at cosmic extremes, from the event horizons of black holes to the edges of the observable universe, examining how these environments test the limits of both Newtonian and Einsteinian frameworks and hint at deeper layers yet to be discovered. But for now, we rest with the knowledge that gravity operates everywhere, quietly shaping life, matter, and the cosmos, a constant companion and an enduring enigma. When we extend our gaze to the extremes of the cosmos, gravity transforms from a familiar companion into a profound and sometimes terrifying force. Black holes, neutron stars, and other exotic objects offer laboratories where the rules of physics are stretched to their limits. Near a black hole, space and time behave in ways that defy everyday intuition. Tidal forces stretch objects, time slows relative to distant observers, and light itself curves in dramatic arcs. Gravity at this scale is no longer gentle or predictable. It is intense, almost sculptural, shaping the very fabric of the universe. Neutron stars provide another glimpse into extreme gravity, formed from the remnants of massive stars that have exhausted their nuclear fuel. These objects pack more mass than the Sun into a sphere barely 20 kilometers across. The gravitational pull at their surface is billions of times stronger than on Earth. Any object approaching a neutron star would be compressed, stretched, and torn apart. Yet, even within this immense force, patterns emerge. Pulsars, spinning neutron stars, emit precise beams of radiation, cosmic lighthouses, showing us the subtle interplay of rotation, magnetism, and gravity. These phenomena remind us that even in extreme conditions, the universe maintains a kind of elegance, a harmony encoded in the laws of physics. The study of gravitational waves has expanded our understanding of these extreme environments. First predicted by Einstein, gravitational waves are ripples in spacetime caused by accelerating masses, such as colliding black holes or neutron stars. Detecting them requires extraordinary sensitivity, as the distortions they produce are minuscule, far smaller than the width of a proton. Yet in 2015, LIGO succeeded, confirming Einstein's prediction and opening a new window onto the universe. Gravitational waves allow us to hear cosmic events that were previously silent, revealing the dynamics of spacetime itself. These discoveries reinforce the subtlety of gravity. At ordinary scales, it is a constant companion, predictable and familiar. At extreme scales, it becomes a key to unlocking mysteries of the universe, revealing patterns, anomalies, and behaviors that challenge even our most sophisticated models. Gravity is both the foundation of stability and the driver of extraordinary change. Stars collapse, galaxies merge, and black holes form all under its influence. The force that guides an apple to the ground also orchestrates events across billions of light years. Cosmic expansion adds another layer of complexity. Gravity, which draws matter together, is countered on vast scales by dark energy, causing galaxies to recede from one another. The tug of gravity is immense, yet insufficient to halt this acceleration. The interplay between attraction and repulsion, mass and energy, creates a dynamic universe in constant flux. Here, gravity is part of a larger cosmic narrative, intertwined with phenomena that remain largely mysterious. In contemplating these extremes, we also encounter theoretical frameworks that stretch the imagination. Black holes suggest connections between gravity and entropy, information, and quantum mechanics. The holographic principle proposes that all the information contained within a volume of space may be encoded on its boundary. This challenges conventional notions of space and gravity, suggesting that what we perceive as volume may emerge from more fundamental processes at the edge. Such ideas invite us to see gravity as a mere force, but as a manifestation of deeper, hidden realities. Even the edges of the observable universe test our understanding. Galaxies billions of light years away are influenced by gravitational interactions across cosmic distances. Light from those galaxies bends subtly as it passes massive objects, producing effects known as gravitational lensing. These phenomena allow astronomers to map unseen matter and probe the distribution of dark matter. Once again, gravity proves to be both ordinary and extraordinary. It governs motion on every scale, yet it hints at forces and structures we cannot directly see. In the laboratory, physicists explore gravity's subtleties with remarkable precision. Experiments measure how masses interact at microscopic distances, searching for deviations from Newtonian predictions. These experiments test whether additional dimensions or new forces influence gravitational behavior. Even minute anomalies could reveal profound truths, reshaping our understanding of spacetime, mass, and motion. Gravity, it seems, is a constant source of insight and discovery, inviting careful observation and patient reflection. Let us return for a moment to the human scale. Our daily experience of gravity is stable, comforting, and rarely questioned. We walk, lift, throw, and sit, all under its influence. Yet the force that feels so ordinary is intricately connected to the vast cosmic machinery we have been describing. Every step on Earth resonates with the motion of planets, the curvature of spacetime, and the subtle tug of distant galaxies. Our bodies, adapted to this force over billions of years, embody the quiet dialogue between matter and gravity. The meditation here is simple yet profound. Gravity is not only a force, it is a thread connecting the micro and macro, the familiar and the exotic, the immediate and the cosmic. It shapes life and death, birth and decay, structure and dissolution. It organizes matter, guides motion, and encodes patterns that we are only beginning to decipher. Every object, every movement, every interaction participates in this grand choreography. Even speculative ideas about the universe invite reflection. Some propose that gravity may be an emergent phenomenon arising from quantum information. Others suggest that gravity could vary subtly across cosmic distances or be influenced by hidden dimensions. These concepts are tentative, yet they illustrate a central truth. Gravity is far from fully understood. It is a lens through which we glimpse the architecture of reality, hinting at connections and structures that remain largely invisible. As we continue to explore, we see that gravity is a teacher in more ways than one. It teaches patience because its effects accumulate over vast timescales. It teaches humility, reminding us that even brilliant minds only grasp fragments of its nature. It teaches curiosity, urging us to observe, measure, imagine, and reflect. Gravity is both a companion and a challenge, comforting in its reliability and inspiring in its mystery. Consider again the cosmic extremes: a star collapsing into a black hole, a neutron star spinning rapidly, galaxies rotating faster than expected, the universe expanding at an accelerating pace. Each scenario tests our understanding. Each observation offers a new question. Gravity, simple in appearance, is extraordinarily complex in reality. It is a force that shapes everything we see, while hinting at realms beyond our perception. And in this realization lies wonder, the ordinary pull beneath our feet, the trajectory of a thrown stone, the rise and fall of tides, all are connected to phenomena on the grandest scales. The curvature of spacetime, the influence of dark matter, the echoes of gravitational waves, the shape of the universe itself, these are all part of the same tapestry. Gravity binds us to Earth and links us to the cosmos. It is ordinary, extraordinary, intimate, and cosmic simultaneously. Finally, we pause to notice a quiet truth. Gravity, the force we encounter every moment, is not fully understood. It behaves predictably in many contexts, yet it hides surprises, challenges, and profound insights. It is both tangible and abstract, immediate and timeless. It is a force we can measure, a pattern we can observe, and a mystery we can contemplate. Every step, every breath, every orbit, every collision in the cosmos is shaped by this invisible hand. In the next part, we will explore gravity's subtle interplay with time, energy, and the fundamental structure of the universe, moving closer to the frontiers of knowledge where classical, quantum, and cosmic perspectives converge. But for now, we rest with the understanding that gravity, in all its forms and scales, is a constant companion shaping life, the cosmos, and the mind alike. Gravity is not merely a force acting in space. It is intimately tied to time, shaping its passage, bending it in the presence of mass, and linking motion to chronology in ways that are both subtle and profound. Einstein's general relativity revealed that time is not absolute. It flows differently depending on gravitational strength. Clocks at the top of a mountain tick slightly faster than clocks at sea level. Satellites in orbit experience time differently from those on Earth's surface. The ordinary experience of minutes and hours is, in fact, intertwined with the curvature of spacetime, a subtle reminder that gravity is more than the sensation of weight. This interconnection between gravity and time invites reflection on scale and perspective. On Earth, we rarely notice these differences. Our lives unfold in daily rhythms that seem uniform and reliable. Yet, as we extend our gaze, the same principle governs the motion of stars, the orbit of planets, and the evolution of galaxies. Time itself becomes a variable, stretching, contracting, unfolding in response to the presence of mass and energy. Gravity is the lens through which the universe measures itself, subtly guiding the progression of all phenomena. In the cosmos, this effect has dramatic consequences. Black holes, regions where gravity is extreme, distort time so profoundly that an observer near the event horizon would perceive the universe outside moving at unimaginable speeds. Light itself struggles to escape. Here, gravity does not merely attract. It dictates the flow of time, the movement of energy, and the very structure of reality. The force we experience daily is, in these extreme environments, a sculptor of spacetime itself. Even in more familiar contexts, gravity's influence on time has practical implications. GPS satellites, for example, rely on precise timing to function correctly. Without accounting for gravitational time dilation, navigation systems would quickly accumulate errors. This is a tangible reminder that the curvature of spacetime, the invisible bending of the continuum by mass, is not an abstract concept, but a real and measurable effect. The same force that shapes galaxies also governs the reliability of a map on your phone. Gravity also interacts with energy in ways that challenge intuition. As objects fall, they convert potential energy into kinetic energy, accelerating predictably according to mass and distance. This simple principle governs motion on Earth and throughout the cosmos. Yet, when we examine energy at quantum scales, the picture becomes more complex. Fluctuations, virtual particles, and subtle quantum effects interact with gravitational fields, suggesting that energy and spacetime are deeply interwoven. The flow of energy, the accumulation of mass, and the geometry of spacetime form a triad that underlies all structure. In this framework, we begin to see gravity as a standalone phenomenon, but as a reflection of deeper principles. The force we feel is a manifestation of geometry, information, and energy. It emerges from the interplay of mass and spacetime, yet its origins may be rooted in even more fundamental aspects of reality. The curvature of space, the flow of time, the distribution of energy, all these are part of a hidden choreography, one that guides the universe with subtle precision. We also encounter gravity's role in the stability of matter. Stars shine, planets orbit, and galaxies persist because gravity mediates the delicate balance between opposing forces. Electromagnetism, nuclear forces, and gravity interact to create structures that can last for billions of years. The stability of our own planet, the persistence of oceans, the consistency of seasons, all arise from this intricate dance. Gravity, often taken for granted, is the quiet custodian of cosmic order. At the edges of theoretical physics, researchers explore even more radical ideas. Some propose that gravity may emerge from information itself. The holographic principle suggests that the behavior of a volume of space can be described entirely by data on its boundary. In such a universe, gravity is not a fundamental force, but a consequence of the distribution and flow of information. This concept challenges intuition, yet it offers a compelling framework for uniting general relativity and quantum mechanics. Gravity, in this view, is a shadow of deeper processes, a reflection of an underlying informational architecture. The thought is both humbling and inspiring. Gravity, so familiar in daily life, may encode truths about the nature of reality that are far beyond ordinary perception. Every falling object, every orbiting planet, every bending of light is a hint, a footprint, a whisper from the deeper structure of the cosmos. The ordinary sensation of weight, the stability of a chair or a building, may be expressions of the same principles that guide black holes and shape the evolution of the universe. We might also consider the subtle variations of gravity across space and time. Local mass anomalies, mountains, subterranean structures, and ocean currents all create measurable deviations in gravitational strength. Over geological timescales, the movement of tectonic plates, the formation of mountains, and the shifting of continents further alter local fields. Gravity is dynamic, evolving alongside the Earth itself, and its patterns are recorded silently in the contours of the planet. Even in this apparent constancy, there is motion, fluctuation, and impermanence. As we reflect on these ideas, it is useful to contemplate the human experience of gravity once more. Every motion, every gesture, every step interacts with this force. The pull beneath our feet, the stability of our environment, the arcs of thrown objects, all are guided by gravitational influence. Yet beyond perception, gravity orchestrates motions on scales that dwarf human imagination. Stars dance in galaxies, galaxies cluster, and the universe expands, all under the same principle that causes an apple to fall. The ordinary and the cosmic coexist in a continuous dialogue. Gravity also shapes the flow of energy across the universe. It concentrates matter to form stars, facilitates nuclear fusion, and governs the distribution of gas and dust. It mediates the transfer of angular momentum, drives the spiral patterns of galaxies, and orchestrates the collapse of stellar cores. Energy, mass, and space-time are inseparable. The dance of matter is inseparable from the pull of gravity, and the energy of the cosmos unfolds in patterns dictated by these interactions. In contemplating these relationships, we recognize that gravity is both predictable and mysterious. Its principles allow for remarkable precision, yet its depths remain largely unexplored. From the smallest laboratory experiments to the largest cosmic structures, gravity operates consistently, yet hints at hidden layers of reality. It is an ever-present companion, a force shaping the known, and a doorway to the unknown. As our meditation continues, we notice that gravity's subtlety and reach encourage both reflection and curiosity. It reminds us that what feels ordinary may hold profound significance. It invites patience in observation, rigor in study, and imagination in interpretation. Each discovery, each anomaly, each insight reveals only part of the story, leaving space for wonder and further exploration. Gravity, in all its scales and manifestations, connects the familiar to the extraordinary, the tangible to the theoretical, the immediate to the eternal. It is a force, a pattern, a principle, and a mystery. And it is in this duality of being both understood and elusive that gravity reveals its quiet power. We may measure, calculate, and predict, yet we also marvel, speculate, and imagine. In the next part, we will examine gravity's role in the evolution of the universe, from the formation of the first stars to the shaping of cosmic structures, considering how this force has guided the emergence of complexity over billions of years. But for now, we rest with the knowledge that gravity is a continuous thread, connecting matter, energy, and time, guiding both the motions of galaxies and the gentle weight beneath our feet. Gravity's influence on the evolution of the universe is subtle, persistent, and extraordinary. It is a force that sculpts matter into structure, shaping the cosmos over billions of years. In the earliest epochs after the Big Bang, matter was distributed almost uniformly, a nearly featureless expanse of gas, energy, and dark matter. Yet gravity, ever present, began to gather and concentrate this matter, amplifying tiny fluctuations into seeds of galaxies, stars, and clusters. The universe transformed from a smooth canvas into a complex, textured tapestry. The first stars emerged from immense clouds of hydrogen and helium, collapsing under gravity's steady pull. Within these furnaces, nuclear fusion ignited, producing light, heat, and heavier elements. Gravity was both the catalyst and the framework, drawing matter together while regulating the balance between collapse and explosive pressure. Stars burned, evolved, and died, seeding the universe with the elements that would later form planets, oceans, and life itself. Gravity was the architect behind every pulse of creation, orchestrating the conversion of simplicity into intricate complexity. Galaxies followed, vast collections of stars bound together by gravitational attraction. Spirals, ellipses, and irregular forms emerged as matter interacted under gravity's influence. Clusters and superclusters formed, linked by the invisible scaffolding of dark matter, revealing a cosmic web that stretches across billions of light years. Gravity shapes not only the motion of matter, but the very organization of space itself. Without it, stars would remain scattered, galaxies would never form, and the universe would remain a featureless void. The ordinary force we experience on Earth is, at these scales, the engine behind cosmic architecture. Within galaxies, gravity governs stellar orbits, planetary systems, and the delicate balance that allows habitable worlds to exist. Planets coalesce from accretion disks around newborn stars, their paths shaped by gravitational interactions. Collisions, resonances, and perturbations guide their motions, producing stable systems or chaotic upheavals. Gravity is at once gentle and unforgiving, a sculptor of worlds and a regulator of cosmic order. The Earth itself is a product of these dynamics, a delicate balance forged by gravitational interactions over billions of years. The influence of gravity extends to the emergence of complexity in living systems. By concentrating matter into stars and planets, providing stable orbits and climates, gravity has created environments where life can arise. Tides, driven by the pull of the moon and the sun, influence ocean currents, coastal ecosystems, and even the behavior of species. The slow movement of continents, governed by tectonics and gravity, shapes habitats and evolutionary pathways. Life is inseparable from the gravitational context in which it exists. Yet gravity is not merely a force of order. It also drives change, transformation, and cycles of destruction and renewal. Stars collapse, explode, and recycle matter into new generations. Galaxies collide, merging and reshaping their structures. Planetary surfaces shift, mountains rise, rivers carve valleys, and ice sheets advance and retreat. Gravity, in its quiet persistence, orchestrates these processes over immense timescales, creating the conditions for both stability and transformation. Consider the interplay of gravity with dark matter and dark energy. Dark matter, invisible yet influential, provides the gravitational scaffolding that allows galaxies to form and persist. Dark energy, on the other hand, drives the accelerated expansion of the universe, counteracting gravity on the largest scales. The cosmic dance between attraction and repulsion, between mass and energy, produces the universe's grand architecture. Gravity's influence is both local and cosmic, shaping everything from the fall of a stone to the distribution of superclusters. At the smallest scales, gravity's role in quantum systems remains a profound mystery. How does the pull of mass interact with the probabilistic nature of particles? Do gravitational effects influence quantum coherence or entanglement? These questions are open frontiers, hinting at connections between the familiar force we experience daily and the deep structure of reality. Even as we map galaxies and measure cosmic expansion, the essence of gravity at the intersection of the quantum and the cosmic remains elusive. Gravity's persistence also teaches us patience and perspective. Processes that shape the universe unfold over billions of years, far beyond the span of human experience. Stars live and die over millennia, galaxies merge over millions, and the universe expands across billions. To understand gravity is to attune ourselves to these immense timescales, to appreciate the slow accumulation of effects, and to recognize our fleeting presence within a vast continuum. This perspective invites meditation on the interconnectedness of all things. Every particle, every planet, every star participates in the gravitational web. The Earth, our solar system, and our galaxy exist because of countless gravitational interactions over cosmic time. Each of our bodies, moving, breathing, thinking, and living, is bound to these processes. We are, in a subtle but profound sense, participants in the ongoing gravitational narrative of the universe. Even human technology is shaped by gravity. Satellites orbit precisely because engineers understand its influence. Rockets escape Earth's pull only by countering it with energy. Bridges, buildings, and vehicles are designed with gravitational forces in mind. Our ability to manipulate and navigate these forces reflects not only ingenuity, but a deep, ongoing engagement with the principles that govern matter and energy. Gravity is both a teacher and a constraint, offering lessons in balance, precision, and foresight. At the frontiers of science, researchers continue to probe gravity's limits. The search for quantum gravity, the study of black holes, the mapping of dark matter, and the observation of gravitational waves all reveal new facets of this force. Each discovery reinforces the sense that gravity is ordinary and extraordinary simultaneously. It is simple enough to feel beneath our feet, yet complex enough to challenge the most sophisticated models. It is familiar and mysterious, intimate and cosmic. As we meditate on these patterns, it becomes clear that gravity is more than a physical force. It is a thread connecting scales, phenomena, and epochs. It links the formation of the first stars to the evolution of planets and life. It connects the rhythm of tides to the orbits of galaxies. It binds ordinary experience to cosmic processes. Every motion, every interaction, every structure is influenced by gravity, and in this influence lies both predictability and wonder. The universe, shaped by gravity, is both ordered and dynamic. Galaxies rotate, clusters form, stars are born and die, planets orbit, and life emerges. Gravity orchestrates this continuity, providing stability while allowing transformation. It is a subtle but omnipresent force, a constant through time, shaping both the seen and the unseen. To understand gravity is to glimpse the architecture of the cosmos, the patterns that guide matter and energy, and the hidden structures that give rise to complexity. Finally, we may reflect on the human response to this force. We measure it, observe it, model it, and yet we are still in awe. Gravity humbles and inspires. It invites curiosity and patience. It encourages us to see both the ordinary and the extraordinary in the world around us. The pull beneath our feet connects us to stars, galaxies, and the structure of the universe itself. Each moment of life is intertwined with this ancient, persistent force. In the final part, we will bring together the insights from these meditative explorations, reflecting on gravity's role in shaping the universe, life, and our perception of reality. We will consider how understanding gravity can alter not only our scientific knowledge, but our sense of connection to the cosmos, grounding us while inviting wonder. Gravity is the invisible thread that connects everything we know, and much that we have yet to understand. From the steady pull beneath our feet to the colossal forces shaping galaxies and black holes, it is both familiar and extraordinary. As we reflect on its reach, it becomes clear that gravity is more than a force. It is a principle that organizes the cosmos, guides the emergence of structure, and influences the flow of time and energy. It is a rhythm, a pattern, and a presence that binds the universe together in ways both subtle and profound. We live our daily lives under the influence of gravity almost without noticing. We walk, run, jump, build, and rest, confident in the constancy of its pull. Yet this seemingly ordinary force is intimately connected to phenomena far beyond our perception. Stars orbit, planets spin, and galaxies evolve because of gravity. It is the invisible hand shaping the universe, from the smallest pebble to the largest cluster of galaxies. In this sense, every moment of life is quietly orchestrated by a force that is at once ordinary and magnificent. Consider the paths of planets in their orbits. The delicate balance between gravitational pull and momentum keeps them in stable motion, allowing conditions suitable for life to emerge on worlds like our own. Gravity governs tidal rhythms, influencing the ebb and flow of oceans, the cycles of coastal ecosystems, and the subtle patterns that affect countless species. It shapes the weather and climate, the formation of mountains, and the slow drift of continents. Gravity is the silent architect of stability and transformation alike. At cosmic extremes, gravity reveals its astonishing versatility. Black holes distort space-time, bending light and warping the flow of time. Neutron stars, spinning with incredible speed, display immense gravitational fields that would crush ordinary matter. Even as we study these phenomena from afar, we are reminded that gravity operates consistently, yet manifests in ways that challenge our intuition. The very structure of reality bends to its influence, inviting us to reconsider what we take for granted. Gravity also interacts with time in subtle, profound ways. Clocks in strong gravitational fields tick more slowly than those in weaker ones, revealing that time is not uniform, but a variable shaped by mass and energy. This relationship between gravity and time connects human perception to cosmic events. The seconds we measure on Earth are linked, in intricate ways, to the mass of stars, the curvature of spacetime, and the movement of distant galaxies. Our experience of the ordinary is inseparable from the vast machinery of the universe. In theoretical physics, gravity continues to provoke deep questions. Quantum mechanics and general relativity remain difficult to reconcile. Is gravity a fundamental force, or does it emerge from deeper, unseen principles? Does information encode spacetime and give rise to the effects we interpret as gravity? These questions invite humility and curiosity, reminding us that our understanding is provisional, that there is more to discover, and that even the most familiar force can conceal profound mysteries. From the smallest laboratory measurements to the largest cosmic surveys, gravity offers insights into the underlying structure of reality. Experiments with atomic clocks, gravitational wave detectors, and satellite observations reveal subtle variations in gravitational fields. These measurements confirm the precision of Einstein's equations while leaving room for new discoveries. Gravity, simple in appearance, is complex in reality, a bridge between the observable and the hidden, the immediate and the cosmic. Human life is shaped by gravity in ways both practical and profound. Engineers calculate its influence to build bridges, design vehicles, and launch satellites. Our physical form is adapted to its pull, bones and muscles working in concert to counteract the constant downward force. Every gesture, every movement, every heartbeat is influenced by gravity. We are participants in its effects, embedded in its continuous rhythm. Even as we reach toward the skies with rockets and satellites, we remain grounded by this fundamental force. Yet gravity is also a source of wonder. It connects the familiar to the extraordinary. The fall of an apple mirrors the collapse of a star. The orbit of the moon echoes the motions of distant galaxies. Light bends near massive bodies, revealing invisible structures. Each observation invites awe, curiosity, and reflection. Gravity teaches us to notice the ordinary, to perceive the extraordinary, and to consider our place within the vast continuum of cosmic processes. As we look to the future, gravity remains a frontier of exploration. The search for a quantum theory of gravity, the study of dark matter and dark energy, and the investigation of extreme cosmic environments promise new insights. Each discovery deepens our understanding while preserving the sense of mystery that has always accompanied our contemplation of the cosmos. Gravity is a companion in this journey, guiding, shaping, and challenging our perceptions. In meditating on gravity, we recognize a profound interconnectedness. Every motion, every structure, every moment of life is part of a larger gravitational narrative. The pull beneath our feet links us to stars, planets, galaxies, and the unfolding universe. Every rhythm of the cosmos is reflected in the ordinary movements of daily life. Gravity is at once intimate and cosmic, predictable and mysterious, simple and infinitely complex. As we conclude this exploration, it is worth pausing to appreciate the ordinary force that surrounds us. The gravity that keeps us grounded is the same force that shaped the stars, guided the formation of galaxies, and orchestrated the emergence of complexity. It is a constant presence, a measure of continuity, and a source of wonder. To live, move, and observe under its influence is to participate in the ongoing story of the universe. If you have followed this journey through the nature of gravity, from the weight beneath your feet to the farthest reaches of space, you may feel a sense of connection and perspective. We hope this exploration has inspired curiosity, reflection, and a quiet appreciation for the forces that shape our existence. If you found this journey calming or thought-provoking, consider subscribing to the channel, sharing your thoughts in the comments about where you are and what time it is can also create a small connection across the distance. These gentle gestures help this exploration reach other minds who may find wonder in the ordinary and the extraordinary. Thank you for being part of this journey. Rest now, allowing these reflections to settle, carrying a sense of gravity, connection, and quiet all into your dreams.